Excellent. 4 o'clock sharp, and we would like to start the session. First of all, I'm seeing quite a lot of people who have joined the session. Thank you very much. When we started off, we honestly, truth be told, we didn't really expect so many people to show this level of interest. So we're grateful that so many people have decided to be with us and join us. We will obviously see a lot more people coming. We had about close to about 350 plus, or 370 registrations for this session, which is incredible. And let's see how many people will register and actually also turn up as well. That's an interesting one. So today's topic, we kind of knew it's an interesting hot topic right now. And we kind of wanted to discuss about it because that's an area which a lot of people are interested in and sometimes have a bit of a hesitation, have a bit of a struggle as to how do I really get about starting. And the good news is that I have probably the easiest job. The easiest job is to ask the questions, and I have 4 very esteemed panelists who will be able to give, demystify, clarify, and explain how to get this going. So I'm really looking forward to it. I don't know about the 4 of you. So first of all, thank you very much, the panelists. As a usual practice, we don't really go into the extent of explaining who and what they are. I think all 4 of them have LinkedIn profiles. I recommend for you all to take a moment and kind of get understand who they are from. 3 of my colleagues from OCTAVE, obviously Siddarth is also considered as part of OCTAVE, but obviously representing McKinsey, who is here. So thank you to the 4 of you for taking the time. It is the middle of the week. You kind of start to see the life creeping back to you by tomorrow onwards, but today it's the middle of the week. So I want to make sure that we get starting. So for everyone, thank you for joining this webinar, which is part of our virtual experience series about building your advanced analytics career, where to start, and the skills that are really set you up. Now, with a little bit of a introduction that I can give is that when we say advanced analytics, it's a term that has been very loosely used by so many people. If you ask HR, they have a slightly different. If you ask a science statistician, they'll have a different understanding. If you ask a software programmer, there's a different understanding. There's a lot of different understandings out there, and that is a reflection of the fact that this industry and area is fast growing and under rapid development all the time. So as a result, I don't think anybody's right or wrong. It's just different ways, but it's really important to get to the nuts and bolts of it. Of course, we can't exclude the word data science, which is probably the trophy word around advanced analytics. But I think we'll kind of get into what does data science mean in advanced analytics or vice versa as well. As I mentioned, I have extraordinarily privileged to have 4 very esteemed, very qualified 4 panelists today joining me. And what I would like to do is to start off asking all of the 4 panelists to give opening remarks about the topic and provide some context, and we'll get into the questions. For everybody who is listening, once again, thank you and welcome to the session. The chat is open. Please leave your questions here. I strongly urge you for a couple of housekeeping stuff. Please make sure that you are on mute. You also have your camera switched off. We didn't want to do a live. We just thought we'll just invite you to our meeting and for you to have a much more closer feel for the interaction with us. Second part of it is that please note that we are recording this session. We might make it available publicly later on as well, but that decision is not yet made. So any questions, clarifications you have, there will be about 10 minutes time. Later on, we'll ask. We will make for those questions, but we'll make it. But let me start off with the opening remarks. Let me first come to maybe, I'm just picking you randomly here. Maybe we'll come to Sid. Sid, what are your thoughts about the topic and this area? Because I know we have quite interesting questions from you to ask as well.
So first of all, thank you all for joining. My name is Siddarth. I've been, and I believe I can say that I've been practicing analytics for the last 15 years. So that's a gist about me. But I won't get into too much details, but I think I'll only touch upon two points. The first one is what we have seen in the last 15, 20 years is a huge evolution in terms of not only how we do analytics, but how we consume analytics, right? So we have, back when I started my career, we didn't have Azure, we didn't have AWS, we didn't have a concept of platform, we didn't have pipeline, right? Most of the analytics was done in SaaS. That meant that if I still remember I used to run a model and, I'll just run it on a platform and I'll go away, right? I'll come back after 2 days, the model would be done. It might have failed, it might have succeeded, right? But nowadays we have this, because of all the development which has happened technologically, we have these platforms where you can parallel compute, right? Multiple things can be done in parallel. So the speed of execution is a great advantage, right? Not only because of the fact we can have these models computation which can be done very fast, but also the fact now we can iterate a lot more, right? So that's one. Second is what we have seen is like we talk about deep learning a lot of times, right? The deep learning is not a new topic. It has always been there. 1950s, 60s, there was a lot of research done in these kind of algorithms. But I think the revolution really started to happen when we started to get more and more data and the compute power. Most of you might know that the only reason we are talking about deep learning is because of the amount of data available and the compute power we have, right? So in short, what I want to mention is we have made big leaps in terms of what we can do now. And I'm sure in next 10 years or so, things would be significantly different, right? I'll pause here. I won't get into too much details. Otherwise, this is a topic I can go on forever. But I'm seeing Rohan, and he's telling me to stop.
No, I was not, but I was going to. But listen, I want to hear more about how you started, and I think that's the story we want to get into. The work in terms of what data science is capable of doing, I think there's 119 people in this call who are convinced that it makes something really important. If you look at any job report lately, data science, advanced analytics is highest paid, most in demand type of roles. So idea is, how did you get in? Maybe it was an accident like mine. So we'll get into that bit. But for opening remarks, let me come to Basant. Basant, my friend from India.
Yeah. Thank you, Rohan. Thank you, everyone. So let me start with the whole ecosystem is like this is the first question. I think at the very start we should have a level set that there are three major areas of disciplines and streams, which is data engineering, data scientist, and data science and analytics. And it is a very good question for the starters to chase that what each of these fields, what challenges they offer and what kind of role in each of these streams we need to do. For example, in data engineering, it is a heavy technology things. You collect the data and maintain the data platform. So it's a very heavy, technically very heavy. And data scientist is where you have this understanding of mathematics, statistics, and write algorithms, machine learning algorithms. And the analytics field is where you write this BIs, dashboarding, and do SQLs, data warehousing, and stuff. Let me come to the data engineering side where I belong to and try to answer your question, Rohan, that how one should start a career on data engineering side. So data engineering, as I said, that is in the whole ecosystem. If you see the left-hand side is data producers, right-hand side data consumers. In between, this is the platform where the data engineer maintains the whole platform. So data engineering is basically heavy technology and it's intersection of many other technologies as well. Starting with your data engineering core technologies like SQL, Spark, and a few orchestration technologies and so on, but it has a good intersection with software engineering, good intersection with databases and the cloud as well. And because of this, as Sid was mentioning, the explosion in the requirement and use case side, there has been explosion on the technology side as well, and that makes it is challenging and exciting as well. To start with, one should look for the skills in the data engineering side. I think it would be to name a few. It would be SQL, which is kind of skill which is a lifetime skill, right? Everybody should have a good grip on SQL, whether it is you're a functional, techno-functional, or technical guy. And apart from that, I would name Apache Spark, which has become a de facto in terms of big data processing engine and the cloud. So these are the three things I would say a must-have to start a career on the data engineering side. Yeah.
Basant, very interesting. We are going to get into that. Again, I want to kind of come back, but Poornika, what do you think? We had Sid's opinion, we had Basant. How have you been? How have you got into this? Tell me a little bit about your opening remarks. We'll get into the nuts and bolts a bit later. Yeah.
Sure. Thanks, Rohan, and thanks everyone for joining. So I will briefly touch on a bit on business perspective, Rohan, how I see advanced analytics and the career opportunities. So advanced analytics, we all know like it's a growing field and it's definitely a promising field to be in terms of career opportunities. And I think it will be the case even for the next decade, at least. So why it's growing is definitely it adds value to the business, and that's why businesses are investing on these advanced analytics technologies. But why it is important to the business is actually the data is being an asset, and data analytics is the way that they leverage the key data asset to create value to the business. So by creating value to the business, they can be ahead of their competition, and any business that doesn't adopt these technologies will soon be leave behind, right? They can't compete in the markets and they will have to anyway be investing on these technologies to survive. So I think that's why this is growing and it will definitely grow, and that means a lot of career opportunities. But having said that, we also see that skill shortage, not just locally, but even globally, we see the skill shortage. I think that maybe the fact that this is a relatively new field, but at the same time, we also see that a lot of young students want to get into data science, a lot of universities getting data science into mainstream programs. But I think the young students definitely need some kind of guidance, support to navigate this journey. So I think overall, this is a timely topic, and I'm looking forward for the session to share some of my experiences and hear from other panelists as well.
Awesome, Poornika. Rajitha, you have an absolutely interesting, unique story. We look forward to getting into the details, but opening remarks about building your advanced analytics career.
Thank you, and thank you everyone for joining today's session. So yes, I heard quite a bit of interesting stuff from the other panelists. So the way that I have been to this analytics journey is I started this journey 13 to 14 years ago. So at that time, like similar to Sid, like we didn't have a big concept of big data. And honestly, I don't even know what is machine learning at that stage at all. And we were doing some small stuff with SAS or maybe even in MATLAB functions. So when I started my career, actually, I started with the unstructured data. So if you look at this concept of data, we can divide it into two branches. One is the structured data, where we have like transactional data, so you have like a tabular format. So the other part of this story is where we call this unstructured data, where you work with images, videos, speech files, like these text files. So I actually started my journey with the unstructured data. So in 13, 14 years ago, so where we started to work with the images and the speech. So we were started to work with automotive company in Australia, where wanted to understand and see whether they can implement a Night Rider car with the speech and the visual representations, and tracking the faces while the drivers are driving in different driving conditions. So that's where my journey started. So I didn't start with any structured data at all at that stage. So we were like heavily into the unstructured data. And at that stage, Rohan, like we were doing even this face tracking, face emotional recognition, how we can understand this emotion using unstructured data. But at that stage, even a small thing that we did for understand the face, it was wow factor. Oh, that's fantastic. But now it's not the case, because it's so that's a huge difference, and it's just very challenging for the people in this age to be in the race as well. It's a competition now, right? It's not like when we were starting. Like you have to be develop your skill sets, right? and you need to get highlighted. You have to get highlighted within that particular analytical journey wherever you are. Right? So I started with unstructured data and working with speech and visual informations and try to unlock business values using the visual and the speech information, whereas basically the unstructured data. And later I moved to work with structured data, but it was a heavily, majority of my work, like more than 10 plus years, I heavily work with unstructured data, understanding visual representation, understanding speech representation, the text representations, and that's where my journey started in this particular field.
Excellent. So thank you, dear panelists. We kind of want to get into it. In preparation for this particular webinar, I picked up a small description about what advanced analytics could do. It is important for business. It says enables enterprises to measure track record performance metrics. For facilitating enterprise-wide enhanced decision-making, companies can analyze trends to make critical decisions to engage customers better, enhance company performance, increase profitability. And the models that are use existing data, can simulate several actions, and it goes on. So that's like why there's a bit of a right now, almost like a mindset by the business leaders of a kind of a gold rush into getting into advanced analytics. We are hearing from every organization we are working with saying that they want to build the advanced analytics. It is like the next wave of how they build their sustainable competitive advantage, at least for a short period of time for the organization. This is really, really interesting. And I think that's why it is on high demand. People are seeing the value, etc. Now, what I really want to do is, I think we have about 130, 140 people in the meeting today. Now, I think there are three types of people in this, in very broadly. One is people who are absolutely new and don't know where to begin, what to do type of thing. There is another segment that probably have, kind of put their fingers in and, kind of tested the waters. And there could be people who are like, I am in my middle of my career. Okay, I'm interested in advanced analytics because I feel it is a future thing for me, future-proofing my career. How do I? So I think these are three different segments on it. So we really want to be able to kind of give some kind of a direction and a starting point for all three groups of you, wherever you are. As I said, chat is open. Please feel free to leave any questions or remarks anytime you feel like it. But let me get into this, because one of the things that oftentimes happen with these topics is that one particular area trying to shine a lot more than the others. But from an important standpoint, I would argue that it takes a lot to tango, right? A lot of people, two people to tango, it's just not one person, right? So I think what I want to come to you, Sid, because you have been representing McKinsey, obviously one of the most respected global consulting group, have been in Sri Lanka, have been in this journey with OCTAVE from the beginning, have seen it all, been there, done that mostly. So I'd like to know, if you have to define from the inputs Basant gave or Poornika gave or Rajitha gave, what are the different roles that it really takes to make an advanced analytic project makes? Because sometimes we often think you have to know programming. You have to be, for example, Basant platform engineer. I mean, is that all? Are there other areas that are really important to make an advanced analytics role happen in an enterprise? Sid, what do you think, Sid?
Yeah. So I think interesting question. And again, lot of evolution in last few years, but I would broadly classify it into three big roles. And within these roles, obviously, there would be some nuances which we can discuss. But the first one and the obvious one is data scientist. Data scientist in a single line is a person who takes data, builds some kind of models. And sometimes, while modeling is a very overly used term, a lot of the time for a data scientist is actually spent in analyzing the data. So while technical skills in developing model is important, but one of the biggest skill, which is not only true for a data scientist, but probably any other job in the world, is problem solving, right? Especially given the massive amounts of data we have access to nowadays, right? You might build some charts, you might derive insights, but at the end of the day, you have to combine all of the insights which you are seeing through different sources into something which is meaningful for the business, right? So the first one is obviously the data scientist, which is the obvious one. Second, because now we have these capabilities where, 10 years back, 15 years back, we didn't have these options, right? It was done in a very different way. And thanks to Yahoo and Google, who gave us, this concept of multi-processing and things like that. A data engineer broadly would be a person who will take care of all the pipelines, how the data flows in from different business systems into whatever platform you are working on. Get the data there, then the data scientist takes over, builds their models. There might be some pipeline development work there as well. And post that, how does the business consume the outcomes of the model? And there are multiple ways to do it. It can be through a dashboard. Those outputs can be integrated with the existing systems which are there in the business, right? So data engineer would broadly focus on data pipelines. Now, there might be sub roles within this data engineers, which might be platforms, right? So there has to be a team which supports the platform, right? There is, whether it's AWS or Azure. So there would be a team which will have slightly different skill set, but I'm not classifying them as non-data engineers, but these would be the people who will support the platform. And there are multiple things they would be taking care of. Then the third big role is your delivery folks. Now, there are various terms floating around in the market. Delivery is a commonly used term. There's also a term called translator, which is not your language translators per se, but these are people. The term translator has been defined because these would be the people who will be a bridge between the business folks and the data science and data engineering folks. The reason this role has become so important is, now, if you think about it, a data scientist or a data engineer would think in a very different way, right? Their way of expressing their thoughts is codes, right? While a business person would think in a very different way, right? He wouldn't think about, what would be the cost function of my algorithm, or how do I optimize this code to run in 2 seconds, right? So two different groups of people coming together is always a disaster, right? In human history, two people with very different thoughts, very different expectations coming together, right? So that's where we need a translator or a delivery person who has a knowledge of what's happening on the data science side. Again, he's not a data scientist, but he understands fundamentals of data science. He also understands fundamentals of data engineering, right? And he also understands the business, right? At the end of the day, whatever a data scientist or engineer does, it has to drive some impact for the business. Whether it's revenue, it might be bottom line impact, it might be increasing conversions for customers, whatever it is, eventually it has to translate to a business metric. So this person actually becomes a very important role because this would be the person who brings the full team together. Okay, so those are the 3 broad roles. Now, within these roles, there are multiple nuances, like I mentioned, a person who is doing pipeline work versus supporting platform. There's also a terminology which has become very popular nowadays, machine learning engineer. So there are small nuances within each of the role. Data scientist also would be of different types. There would be the modern age data scientist who will be mostly working on things like PySpark and stuff like that. There would be statisticians, right, who are more used to traditional statistical algorithms. But those are broadly the 3 roles.
Excellent. Say that excellent answer, because the reason I think is that people oftentimes get into bias towards a particular term and all that. And I think out of the 3 things that which the area that really gets the glory and the glamour is data science, and I think maybe rightfully so. So let me come back to our chief data scientist of the team, Rajitha. Rajitha, demystify what is data science role in advanced analytics team is, maybe a little bit. And can you just establish some level of skills, competencies that is required to be able to become great data scientists in your journey? You have worked with probably hundreds of data scientists so far. Maybe kind of tell us a little bit about what is the role of a data scientist and what kind of people whom you are seeing coming through for it, what kind of prerequisite needed for someone to start off to be a data scientist. Can you kind of demystify that space for us a bit?
Sure. So before I answer this question, I'll go a little bit one level below. So, Sid mentioned like one interesting point where what we do is basically problem solving. So we have some business problem. We wanted to unlock the business value.
I apologize. I think Rajitha, is it just me or Rajitha paused? Sorry, apologies. Rajitha kind of dropped off for 5 seconds. Is it just me?
No, I can hear you.
Yeah, I think he dropped off. No? Okay, Rajitha,
No,
you're back now. Okay,
Sure.
so go ahead, Rajitha. Yeah.
Yeah, so basically what I've said is I will go one level a little bit down before I answer what is the role of a data scientist and what type of responsibilities are. So one interesting thing that Sid mentioned in the second part of his discussion is what we are actually doing is problem solving. So basically we have some business problem. We try to solve this particular business problem using data and see whether we can unlock this business value, right? So even before you go and talk about this advanced analytics, right? So maybe that particular problem can solve just using doing a simple survey, right? You just go and talk to the people and you basically solve that particular problem. So you just go and do some questionnaire things. So you collect some data, and then you can you have the answer. So and you can look at what it is, what type of data, and and identify the pattern. So these kind of information goes up, and understanding these patterns we known as this business intelligence. So you try to understand historical information or some type of tabular data and try to understand patterns and generate reports and given these stats, right? So that's like a one area where data analysis and the business analysis roles come to play. So we call this type of like descriptive or explain type of analysis. Right? Second part is Sid also mentioned about this, the concept of the statistics, right? So if you look at the statistics, what they kind of do in statistics is the traditional statistics. They try to fit like a predetermined shape for a given data. Like so, we have some data, and then you have the statistical algorithms, and you try to fit it, and then you try to get some information. But the beauty of this advanced analytics is try to go one level above. What they try to do is they try to understand these complex patterns, which might not be able to capture from the general statistics, and try to identify the patterns. So that's what this advanced analytics do. So it's a little bit one level above compared to the traditional statistics aspect. So within this advanced analytics journey, so Sid mentioned fantastically about the three major roles. One is the data science, and the second one is the data engineer, and the third one is the importance of these translators who understand the technical concept and also the concept and the business concepts as well. So those are the three key roles. So one, what I'm kind of more connected to is the concept of the data scientists who are more like a techie people, try to do some maths and stats and understand this beauty of this analytics. So as a data scientist, what we kind of do is we look at the data, try to understand the insights, come up with the models, and understand what is the business insights, and also generate some inputs, also intuition strategies for the translators, so that we call this doctor delivery people, to unlock some of these business values. Right? But if you look at it a little bit deeper in terms of the responsibilities, so there are three key responsibilities that the data scientist or a team is responsible. The first one I can say is, so they basically try to solve business problems using analytics. So that's the number one. Right? So within that number one branch, so what they need to do is they need to identify the business problem first, right? And they convert the business problem into analytical problems. So how can I solve this particular business problem using the analytical problem? So that's the first step. They need to argue, discuss with the wider team. You need the translators, as what Sid mentioned. So that's what you do. Right? The second, the key responsibility within that particular branch is, once they identify this business problem into analytical problem, so they need to do some preliminary analysis with these translators, or we call this delivery team at OCTAVE, right? To understand what is the value you are going to generate. If the value is not good enough, or if it is not worth it, so that particular project is pretty much done. Like, it's no point. It will be just exercise for you, right? So that you can do it in a university, right? In the business point of view, it's not the case. So you need to work with delivery team and understand what is the value by doing some preliminary testing. So that's the first key box that as a data scientist need to engage. So in the first responsibility, you can see there is no coding at all. I didn't do any coding. Right? So I just try to work with the business people and try to solve problems, as Sid mentioned. That's the first.
Is there a name we give to them, or are they also called data scientists, Rajitha? Are those people called business intelligence people, or is it a different role, or is that a part of data scientists?
Yeah, so we call it at OCTAVE, we call this delivery people, right? So understand the technical side and also the business side, but they are heavy into the understand the business level a little bit more compared to a data scientist, because data scientists maybe they might not that interesting about the business side. They might interesting about the maths and the stats. How can I generate like a cost function, or how can I generate some mathematical equation, right? So, but the delivery people, they do understand what is going on in high level, right? It's like operating a washing machine, right? So you know how to put the button, that's good enough for you, right? You don't need to understand how come it says 30 minutes if I put the close, right? So that particular level, I don't need to go through that. If you know how to put the button, this button, this button, this button, well, ultimately after 45 minutes, your clothes are pretty much washed, and I don't care how it came, right? So that's kind of like but for a data scientist, we have to work with these people. So you can see you have to collaborate with these people, right? So the second responsibility that the data scientists need to do is they need to take the ownership and the responsibilities of this end-to-end analytical journey, right? So within this particular journey, so the couple of responsibilities or the tasks that they are going to do is, so first task is they will come up with a simple hypothesis when you are doing the exploratory data analytics, right? Because exploratory data analytics is a huge area. So you can do exploratory data analytics for forever, but you have to understand that what is the value for the stakeholders. Like, do we have to do this type of analysis? If it is not value for the stakeholders, it's no point. So you have to understand what are the hypotheses and go after the hypothesis and generate generate insights by validating the data. So here you need to connect with the data engineers as well, because if you put the garbage in, you are going to get garbage out. So you have to work with the data engineers to understand the quality of the data too, right? So this is the most important part. If you put the garbage in, you are going to get the garbage out. So here, especially the Basant's team, right, will come to play working with the data scientists to make sure that they provide the quality data. So you have to validate the whatever the business, let's say, client data, and make sure that the data is in the quality formats. Once you have it, then you can do some exploratory data analysis to understand what are the preliminary hypotheses that you should go after, whether there's any business insight that we can generate. Right? Once you click that particular plot, then you go to this, this fancy stuff that data scientists are saying that we are doing. Start done machine learning algorithms, and we are saying we are developing machine learning models with fancy coding practices and those kind of stuff. That's where the big part will come to play in that particular end-to-end life cycle. Right? So you develop machine learning models and you try to improve their accuracy, improve their model performance, because you are going to, like, data scientists heavily fighting with three areas in this particular stage. The one is the time. So you have the pressure from, especially from the, let's say, delivery people, I need this done by Friday.
We both are laughing, myself and Poornika are laughing because we know it is true.
So, but then for a technical person, I want to try it out many models and say, I have tried this and that, and then I will come up with the answer for you. But it's not the case, especially when you're working in industry level, because time is money, right? So if you fail in that particular race, the competitor will go, right? Yeah. So Poornika also mentioned this particular stage, like if you don't do analytics now, so your competitor is going to do anyway, right? Yeah. So you have to do anyway. So the one is the time factor. You are going to compete with the time. The second one is you are going to compete with the cost too. Like now, Sid also mentioned about this, cloud platforms. Right now we are having these cloud platforms where you can do many interesting things, and because of the power, we have the huge amount of power and the low cost. So you are going to compete with the cost factor too, because you are going to it will have cost, and also if you have like hiring talented data scientists, data engineers, that's just another cost as well. The third component that the data scientists are heavily struggling is the performance capture, right? Okay, I have something, it provides 60%, is it good enough? So should I go and talk to the next people or the delivery people or the business people, what will they say, right? So they are going to find time. The second one is the cost, and the third one is the accuracy of this machine learning models, right? So then you have to like collectively take a decision whether you should move on to the next stage. So if you say like, okay, we are good to go, and then you can do the model refining just for the final icing for the model, and you can doing some tunings, and you have something. Then you go to the third key responsibility that you are kind of part. So the third one is you need to make sure that you are practicing these best practices as well, like so you make sure that you support to this in our case at OCTAVE is the platform.
We'll come back to you. Yeah, we'll come back to you because there's a lot of interesting stuff. So I wanted to make sure that we cover the full gamut of it. There's a really great description of what the data scientists do. But let me come to Basant, because Basant, maybe, yes, data scientists need data engineers, platform engineering. People haven't even heard about these roles, with all due respect, to great level when we talk about advanced analytics, because as I said, it's like this, it's like DNA and RNA. DNA takes all the credit, but nobody even really talks about RNA, right? People don't even I think for me, data engineering is more like the RNAs of the advanced analytics. Would you mind just telling us a little bit about what is platform engineering, what data engineering means, what are the different roles in there, similar to what Rajitha gave a very elaborate, very beautiful answer about what the roles and what the areas they look at, but the kind of different things that are involved, because I'm very conscious of time. I want to get to how people start on each of these as a round before that, at the end, before we conclude today. So, and there are a few questions have come in. We'll come to your questions as well. For everybody who had left questions, don't worry, we'll get around to that. Basant, over to you.
Yeah, so as a data engineer is basically we build that platform which supports these consumption patterns like analytics and advanced analytics. What I mean by building the platform is ingesting the data from source in various speed, various format, and in various volume. And that makes the whole data engineering aspect very complex. The various responsibilities what a data engineer perform is like ingestion, processing, data expectation services, and maintaining this platform. This basically it is a little bit of intersection with the software engineering, because there are not only pipeline being developed, but also their framework being developed as a software, so that these things are done in an automated way. I mean, we don't develop the pipelines per data sets. If there are 1,000 data sets, we build the framework which do this task. And because of various reasons, there is shortage of people. There are explosion of use cases, explosion of business unit you need to support. You need to be smart. You need to automate these things so that in a low code manner you can solve it. So this is where software engineering comes into picture. Apart from that, DevOps is also another role where as a CI/CD and maintaining that infrastructure and moving this code base from lower environment to upper environment. So that is another, again, a role of data engineers, a kind of a sub role of a data engineer. Then again, this ML engineering, which when we develop the machine learning models, so pushing this to upper environment, model monitoring, and all those things, that comes under ML engineering. So, and apart from that, there are architects who are building the system, designing it, and seeing in the futuristic version of your platform. I think these are the different roles.
Basant, if I take maybe couple of different step at it, like for example, organization may get, for example, a simple use case like we want to identify customers who are likely to buy something, for example. Like in that case, we probably want to know, for example, where the customer age, where the customers living, where the customer buy, where the customer prefer eating, what kind of a phone the customer has, so that it is an indication of like that. There are different ways that we have to collect certain data, and this data will not be in one place in a beautiful structure. Yes. It's just been all over the place, and it's the data engineer who have to put that in a way that exactly. people in Rajitha's team can actually just kind of put that to say, exactly. This 25 people are like, that's a kind of a role that is in a very, very simplistic. I just idiot proofed it for myself, Basant. Would that be a fair?
That would be a very fair understanding, Rohan. Thank you.
Excellent. So we come back to that, Basant, because we want to hear about your journey also. Poornika, Rajitha spoke about 3 buckets, so we covered 2 already. The third one is delivery. Siddh also, well, actually, Siddh is the one who brought 3 buckets. So the third bucket is Poornika. Yours is from delivery. Would you tell us a little bit about that?
Yeah. So I think Sid very nicely explained the 3 roles at a very high level, the responsibilities. And Rajitha also touched upon some of the responsibilities of the delivery person to go after and, get the timely delivery of the projects. So I think the most important part as a delivery person, I think, as Sid correctly mentioned, bring this technical world and the business world together to bridge that gap between the technical and the business. So usually, I am coming from an engineering background. I know how the technical people usually think. I have been into technical domain in early stages of my career, but coming into delivery, it's altogether a different perspective. You tend to look at problems from the business perspective when you come to that. But usually the technical people look at problems from a technical perspective. So to bridge this gap between the technical and the business is one of the main tasks of the delivery person. And for me, it has always been a rewarding experience because I have been coming from an engineering background. I had this perspective of the both. So coming back to the roles and responsibilities, I think the business problem, again, from the business, we get a very high level or a vague problem, but we have to actually define carefully the part of that problem which can actually be solved through analytics. So that's where the business knowledge is helpful for the delivery person. And then how do you communicate back to the technical people to make it an analytical problem for them? So then again, you have to work with the data science team to structure that properly so that they finally define the analytical problem out of the business challenge that was given. And then after this model is developed, so you have a nice model, then how do you communicate back to the business what this model is actually doing in business terms? So they not necessarily understand the algorithm or whatever inside the model. And also, most importantly, how do you use that insights coming through the model in the business? You can't just get a prediction and give it back to the business, right? You have to package it in one way or the other. And maybe there are certain other interventions you have to act upon and make it really usable at the business end. So that middle part of creating or using that insights to be driven for data-driven decision making or actionable insights to the business, how do you package that? So that whole gamut of in-between thing, I think there's a lot of play from the delivery person along with the business. And I think other than that, I think there's a lot more I can go on, like managing the expectations of different stakeholders, project management, timely delivery, quality delivery. So I can go on, Rohan, but I think mainly those things.
Let me ask you very up question, because you said you came from engineering background, but it is essential for you to do this role to have an engineering background?
No, not necessarily, Rohan. I think it for the business knowledge you can get while doing the business and working with the business for some time, you can actually get the business knowledge. But the technical one, what I think is a plus point for me, because I understand, I think it has been easier for me to adapt to it. Because I understand even by 1 or 2 sentences, I know what kind of a thought process that's going on with the technical team. But I don't think it's not necessarily to come from a technical background to be a delivery person. But for me, it has been a rewarding one.
Excellent. The reason why I asked that question, I apologize, is that I'm following a series of questions being raised by multiple of our listeners on the webinar. This session is asking, I don't have a background in this. I'm from finance background. I'm from that background. Different backgrounds. Where can I plug in and how do I need to plug in? And that's exactly what we are trying to address as well. So I think for me, please correct me if I'm wrong, any of the panelists. I feel delivery is like the most likely the first step in getting into and then figuring out whether you want to do data science or data engineering. Would that be a fair assessment? What do you think, Basant? What do you think on that part of it?
Well, I think as a non-technical person, the delivery would be the right place to start with, and you should have a good understanding of what data science and data engineers do, because you have to interact with them and give their input and give them the input so that they find out things technically for you. But yeah, you're right. I mean, we can start with the delivery to start with for a non-technical person. Yeah.
Okay, let me come back to Sid. Sid, I'm gonna kind of pack you with multiple questions in this one. First one, thank you for, first of all, that beautiful like 3-role type of thing. I think that kind of helps us to understand where can we try to fit in based on our interest and our capability and skill and all that. I mean, obviously, anybody can study data science, anybody can study platform engineering, anybody can study project management or whatever capabilities as well, right? For me, what I really want to know is that with your years of experience, next 3 to 5 years, where do you see this advanced analytics organizations and roles evolve? Because I think that's what you need. If someone starts today, it is kind of, unless you have like, you would have hear from the experts, they have 5, 10, 15 years of experiences. Some of the people have been in tech industry for 10 years, but if you don't have that background, it's important to understand where the industry is heading and start today to get into that in maybe 2 to 3 years time to mature up for that. So Sid, first of all, is that where do you think the industry and this particular scope is evolving? Number one. If someone is, because most of them are mid-career type of thing, what is the advice you can give about starting their advanced analytics part of it? There are like specific, obviously Poornika, Basant alluded that having a technical background help. Is there anything that people should actually try to do to achieve that as well? So 2 parts of the question. Over to you, Sid.
Yeah. So to answer the first part of the question, Rohan, I think 2-3 things would happen in the next 5 to 10 years. The first one is, and the obvious one, demand for the technical skills, and which includes not only data scientists and engineers and delivery folks, but there would be a lot more demand for some of the supporting roles which nobody talks about. But these are very key roles, like what Basant was mentioning there, platform, people who set up the platform and support during that journey. There would be a lot of support roles. If there are issues with the platform, if there are issues with the model or issues with the application, so there would be support roles, right? So there would be obviously and this is a very obvious thing which we are seeing, that the demand would keep increasing. Now, where is this demand coming from? What we have seen is, like if you go back 15 years, what you'll see is one of the first industries to adopt analytics was banking. Then you started seeing retail and so on and so forth, right? But it was majorly big Fortune 500 companies because of multiple reasons. One being the cost of doing analytics was significantly high. There were no people in the market, so even acquiring people was a significant cost, right? But all of these problems over a period of time have been declining. So while all of this started from certain industries and big companies, now because of the technological advancements we have seen, now setting up a cluster, at least a cluster which can where you can do analytics is fairly simple, right? You have all the tools and technologies available, right? So what we'll see is this demand will come from medium to small enterprises also, right? So earlier it was mostly focused on big enterprises. Now we'll see a lot more demand coming in from medium to small enterprises. Big companies have already done this. They have established. Now what is happening there is the kind of analytics is transforming, right? There was a lot of focus on traditional analytics, but now that focus in the big companies is shifting to a lot of modern age stuff, right? For example, social media, voice, video, those kind of things, again enabled by technology, right? If Google wouldn't have released TensorFlow, it would have been very difficult for us doing any video analytics or image analytics for that matter, right? So I think that's what's going to happen. in terms of demand. So demand will continue to grow. Supply along with that will grow. Wherever there is demand, the supply grows automatically. What will also happen is, I believe, like there is a law around it. Your computing power doubles every X years, right?
Yeah.
So technology obviously will continue to grow. We might not see very big disruptions in technology, right? But we'll see incremental improvements in technology. Like compute power will keep increasing, storage, speed of data transfer will keep increasing. We'll have a lot more tools available. The libraries for data science and data engineers would improve significantly, right? But in 10 to 15 years, and this is my best guess, we might see a big shift. It might be in 10 to 15 years, it might be in 20 years or so. We might see quantum computing, which is going to heavily disrupt everything, heavily disrupt. Like whatever we know in 20 years might not make sense anymore because we'll have so much compute power. We can do a zillion simulations in say a second, right? So, but that's my best guess, probably 15, 20 years away. So that's on the first question. I think the second one is, Rohan, correct me if I'm wrong. The second question was more around how should people start, given some of the people might be, just university graduates. There would be some people who are already in middle management and so on.
Yes.
Right? So I think, and at least, I strongly believe education is important, obviously, but aptitude is more important, right? If you have that kind of a mindset, education is what? You do your bachelor's degree in 3 to 4 years, right? All the content is available on the internet, right? Information has been democratized, right? In fact, you can find much better content than you can in any of the universities, right? For example, Coursera, you have courses by likes of Andrew Ng, Jeffrey Hinton, Jan LeCun, who are like the best in the field, right? So all that information is available, right? But obviously, world works in a very different way. There is still value given to your prior experiences, prior degrees and stuff like that, right? But I think the tactical answer to this is the best place to start is first, if you are going for data science, and I'll try to create that distinction, but Basant, I think you should add in for data engineering related role. For data science, the first thing to do is elementary school statistical book. That's the best place to start because fundamentals are important. That would be the first step, and it doesn't take time. If you are really interested in this, you can read the whole book over a weekend. The second would be to understand the fundamentals of how these algorithms work. A lot of great courses by Andrew Ng on Coursera. They tell you the fundamentals, like behind the scene what happens. Then the third thing is that you cannot learn. It only comes with practice. It's coding. Now, coding, there is a big debate nowadays. Like, do you need to remember all the syntax? Probably not. Nobody remembers the syntax. Everyone Googles the syntax, right? But again, the aptitude comes in. Aptitude is how do you structure the code, right? That's more important, right? Like we always talk about communication skills. Communication skills and language proficiency are two different things. How do you structure the sentences and talk about it? That's communication. Language proficiency is obviously for all of us, English is not the first language. So we'll never be as good, but still we can have very good communication skills, right? So same applies with coding. You should think about how do you design a particular code? How do you make it more efficient? But the proficiency in your code writing, that comes with a little experience, right? The best way to gather that experience is through Kaggle. Compete in competition. First, build your fundamentals, statistics, then few courses on machine learning. All of this can be done fairly quickly. Then you start putting it into practice. And the best way to do it is start competing on Kaggle, right? So this hopefully, again, whether you are from university or you are a mid-level professional, this will help. Now, this is for data scientists. Now, data engineering, the requirement is slightly different. And I would say slightly more difficult also if you are not from a technical background, because it's more focused on technological aspects. writing codes which are super optimized, because that's one of the expectations from data engineers. So I'll let Basant answer that. But lastly, I'll touch upon the delivery folks. I think delivery folks, the good thing is there is no degree per se in the market which qualifies you as a delivery person or a translator for that matter, right? So I think if you have the right aptitude and you feel that this is the thing I want to do, you should just jump into it, right? Worst case, that might not be the thing. You might realize it in 2 years. You can always go back to what you were doing earlier, right? So that's my only advice. But data engineering, I wouldn't comment too much on it because it's a very technical field. I would rather let Basant comment.
I'm happy that you said 2 years because I have 6 months more to think about. Right, okay. Basant, with that, let me come back to you on the data engineering part of it, right? I mean, I think just taking the cue from Sid, I would really love to hear. I don't think you set out saying I want to be a platform. Did you really set out, coming from, school and all saying I want to do? I'm sure nobody really starts like that, right? So can you just describe your journey so far and maybe answer to the question to what Sid said about platform engineering capabilities? And just before you start, Basant, there are a few questions on the chat. A few of the questions I will not pick up because I don't think it's really in alignment with what we are discussing today in this particular discussion, especially around challenges in the organizational one. Those are very unique, specific ones for your organization. Then there is discussions about pay. Those I think we will kind of not have it in this webinar, so I will not take up. There are a few other specific questions we'll take up after Basant's answer. Basant, over to you.
Yeah, so my journey started as a database developer. So I was part of Oracle and part of their core development. So there I learned this internals of databases, and then I moved to the programming side of it. And good 6 years spent time in the core Java design patterns, microservices, and so on. And the data engineering field is basically marriage of these two things, right? Databases and how do you handle the data, store the data, query the data, and there are frameworks and things you need to do where the programming comes into picture. And the third angle is the cloud, right? So these are the three major pillars of data engineering, and because of the explosion of these technologies, cloud offering, open sources, it has become a very dynamic field. I mean, there are tons of technologies there in one technology family, and for an entry person it will be very difficult and sometimes very confusing that what to read and what to not read, where to go in depth, and so on. So my suggestion would be to start with we should visualize the T alphabet, where the horizontal part of the T is your covering the breadth part of it, and the vertical part is covering the depth. At any stage of your life, you should see what is that you should cover as a breadth and what you should cover as a depth. Now, in the starting side, the breadth side of it is basically you should be aware of 2 hours, 4 hours understanding of the technology, why they exist, what is the reasoning behind it, where to use them. That is, I'm calling it breadth. The depth is where you go and understand the fundamentals, understand the under the hood working of it. What I would suggest on the data engineering side, under the hood means the vertical part of it is you should pick one technology from each technology family. You can pick from a database side, let's say, one RDBMS, let's say SQL Server or Oracle. From NoSQL side, Cassandra. From programming language side, you can use Python. From distributed processing system, you can use Spark, and so on. There are messaging system like Kafka. There are technology family, and it could be limited technology family. Choose one technology, part of that technology family. Understand this very well. And this is the same analogy when we used to hear this, right? Once you understand that coding in one language and develop your logic in, let's say, Python, you will be able to do the coding in C, Java, or any other languages, right? Same principle applies here as well. And same goes with the cloud side as well. So if you understand one cloud, for example, Azure, and their offerings, PaaS, IaaS, and all those aspects, you are in the game. I mean, you will be able to understand other cloud and dominate it very well. So this is how I think your approach should be. And again, data engineering, the word engineering here has a lot meaning. I mean, it is because of the software engineering is a very big part of the data engineering. So your understanding of design patterns, architecture patterns, anti-pattern, and all those things, clean code. There are books available related to clean code and all those things. You should try to read. I mean, YouTube learning and all those things is one way of doing it, but the reading books is still the best way to learn things, right? So yeah, I think these are the things. And then when you want to transform yourself from entry level to intermediate and those levels, then you should also look for under the hood working of these things, and also try to contribute on the open sources. I mean, as an open source, you are putting your time, but what you are getting back is you are seeing something which is well thought through, well designed, well coded, code base. So that is what your learning is. And when you are contributing, you are also contributing in the clean way. That is your learning, not that particular open source or technology. The way you code, the way you design, all those things, once you contribute on open source, that's how basically you learn. Yeah.
Basant, I realize that I need to spend more time with you, but imagine I am just out of school, coming to you and got an interview with you. What are the 3-4 things you look at right now to hire me as a data engineer?
First thing is basically problem solving skills. I mean, if individual is having problem solving, I mean, he can learn, he can pick it up. And from a technology perspective, he should be dynamic in the sense, it is like, this is a field where you need to be dynamic. I mean, gone are those days where Oracle, one ID, one SQL, you will be able to sail through it. But here you have to be dynamic. I mean, you have to be open to learn. So I would like to see whether the candidate is open to learn, open to see things. I mean, it is like the thing which I was talking about, the T alphabet, your personality, if needed to be changed, like in the horizontal part, you need to be like a rabbit who is like everywhere, or like I would take a cricket analogy, like in Kalu Vidarna and Jayaweera, what they did to the World Cup, right? Attacking mode, right? That's how you should be in the horizontal part. In the vertical part, you should be like tortoise. I mean, it is like slow, steady, learn fundamentals, and in the cricket, like people like Dravid, people like Sangakkara, and those people who, I mean, it is very difficult to out Dravid and people like Sangakkara. So you have to be very grounded and learn all this, the basics of it, and this is where you'll be able to shine. You'll be able to put fertilizers to your career plant, and that's how you will grow. Yeah.
Thank you, Basant. A really nice analogy. And sorry about Asia Cup. So Rajitha, coming back to you, I have 2 questions from Hasini who had raised. Let me just ask those questions from you, and then I want to hear a couple of things. One is, she had asked how much of a stat knowledge do you need to be a data analyst, data scientist? Why don't you give it from the entry level, maybe the mid-level 2 requirements? And then very interesting, Hasni, I think I can even take the liberty and say that this is not acceptable, where you can actually do only technical and without having to deal with stakeholders, right? So maybe answer those 2 questions. And Rajitha, I know you have an incredible story that a lot of people don't know. You work for Walt Disney, all of that. Would you like to tell us, just like Basant, where did you start? I'm sure you didn't start saying, I want to be a data scientist. I'm assuming. Am I wrong? And how did you get to here? And what was your journey like? That might be some lessons and learnings for people who are here with us.
Thank you. So I'll take this Ashini's question in terms of this the data analytics things before I talk about my journey. So she was asking about this the role of data analysis, right? So the role of data analysis is I would say like it's probably the first step if you are coming from a mid-level, manager level, or if you wanted to change a career, that might be a good start where you can learn about the fundamentals of mathematics and the statistics, and try to do some data analysis. So in here, the data analysis is you have some historical data and you try to understand the patterns. So the data analysis is heavily doing this type of analytics, and you try to figure it out the insights from a given particular data set or a given historical information you had it from a particular client or a business unit, right? And you don't do any advanced machine learning algorithms, nothing. So you basically, given a particular data set, use your fundamental mathematics and the fundamental statistics knowledge and understand these patterns using descriptive type of analytics. And also you can do like explain type of analytics, why this particular information is driven from this particular data set. So those kind of things are heavily involved with the data analysis. And then you need to have this skill sets like how to tell a storyline, how to write a report. So there's a lot of soft skills will come to play, right? So because ultimately you are going to give this particular information for a non-technical C-level person, right? So who doesn't have any idea about what is this stats and maths and stuff. So your end user might be like a non-technical person. So you always have to keep in mind that you are not talking for a technical people. You are talking for a non-technical people. How can you sell this particular story for a non-technical people? Right? So basically you can't avoid this, the stakeholders part. So you have to have that stakeholders part, and also develop the storylines, like how to tell a story, how to create a simple presentation in such a way that the information will pass it to a non-technical person, right? So there's like a nice even courses for how to create presentations, right? Where should I put the most important information? So there's which colors you should use.
Tell a story like Sangha and Dravid.
Exactly, right? So those type of skill sets will definitely help for data analysis. But you are not doing any machine learning things. You don't do any predictive. You don't do any forecasting, right? So basically, you play with like a very safely in the beginning. That will give you enough opportunity and enough time to develop your stats and the maths, and also develop your descriptive type of part. So once you get into that particular part, we have a passion, right? So then you can move to the this area of data science and understand this machine learning algorithms. What is this machine learning algorithms, and how to use these machine learning algorithms with these new tools, and then you can dig deeper to them, the maths behind it. Like if you are looking for ML engineer type of things, they are very heavy technicals, right? So for them, you really have to have the mathematical background, especially the pure mathematics, right? So like something that I wish I would have taken during my in my career is like I wish I could have done a couple of more pure mathematics courses when I did my engineering degree, but I didn't do it. So that was one mistake I did it actually. Then later I understood, oh my God, I did a huge mistake by not selecting these subjects, especially in my final year, because I had to do the self-studies later, and it was hard for me in this stage. Like you have to keep practicing, you have to put the extra effort, right? So and what I did was I'm kind of competing with myself. I wanted to, I'm always looking for 6 months ahead, Rajitha, or 3 months ahead, and I wanted to see that guy and figure it out, the missing pieces that I'm missing, and try to picture that particular guy and try to come up with that project. So that's what I'm always looking for, 2 years, 3 years. So I'm kind of trying to compete with myself. I don't care about what the other people do. I basically compete with myself. Then automatically you will be keep improving. So if you want to be DS, better start. I would suggest see whether you can start with the data analysis as well, because it's only need fundamental of stats and the fundamental of mathematics and the reporting skills, like storytellings. And then when you get into a place, then you can quickly move to the advanced technical things, right? And the statistics stuff that Hashini was mentioning about the skills that you need. So you need the fundamentals of statistics, understand how to generate like the median, mean, and those kind of stuff. And also you need the understanding of this concept of this hypothesis testing. It's a hugely using in analytics. We are doing this A testing, A/B testings, ABC testings, right? Sometimes we do this multi-arm bandwidth testings. So those are some of these testings that analytical people heavily working on, and I talked about this, especially in this pilot stage, right? So, and hypothesis testings are hugely important. Understand what is type 1 error, type 2 error, confusion matrices. So that's the statistic part you need to know as a data scientist. So that's a huge area, statistics. But that's good enough for you to jump in and learn about the data science and the stats, then you can improve it. But initially, you need to understand the concept of hypothesis testings, type 1 error, type 2 error, AA testings, AB testings, ABC testings, maybe the multi-arm bandwidth testings. Right? So those kind of things, it's good enough for you to. Then there are like advanced testings, like how can I select the test versus control? What are the parameters you need to do? But it's a little bit advanced. But those concepts is good enough for you to be in the data analysis course, and those are the statistics things you need to know. So if you look at my journey, so I came from a computer engineering background. So I didn't know about this data science, machine learning at that stage at all. Like I'm doing this stuff. So I was heavily doing the embedded systems design, working with the microcontrollers and programming microcontrollers with C, and understand how can we develop embedded systems, operating systems, those kind of stuff. Then we were learning a lot of programming skill sets, and at that stage, many of them went as software engineers as their career. So, but what I felt is, for me, it's boring for me, and I felt there's something more I have, but I don't know what to do with this. Right? So I was love this maths and the star stuff, but there's no job opportunities. Right? So, and that's it. There's no job called data scientist or ML engineer. It was heavily into the software engineers. Like if you look at my biology, like majority of the people are software engineers. Right? So, but I was figuring out that there's something that I can do more. And then step by step start to do research, like how can I use my mathematics and the statistics skill sets in my computer engineering area. So I don't want to be just to be a software engineer. So that was one decision I took it, like I'm not going to be like a software engineer. That was boring for me, like doing something and it's a repetitive task. I felt that I have something more. Then I realized, okay, what are the things I need to improve in order to be in this particular part? And then I found out the concept of the data. And there's something interesting that I can use some of these things that I have learned in the university life, especially from the stats and the pure mathematics concepts. And then I found out there's this unstructured data concepts. So then I moved to do with unstructured data, especially in the automotive industry. I try to pick the technical things connected with applied application. So that was another decision I took it. I don't want to do like only theoretical things because I will miss the applied stuff. So I always look for a place when I look at it. I do want to do this, but I need to have some type of application. So then I can relate it, how I can use these things, my technical things here, because I felt in the early stage also like some of the technical things, okay, you can derive the things, but if you started to apply these things, you only need like very simple stuff. We have but complex things, it's not working, right? Or maybe people don't understand what is going on. You only need to do the simple stuff. So I can understand what is the applied side as well. So I always like strategically move to a place where I want to do the technical stuff, but I have to have like application, variety of applications. So then my journey of the Walt Disney started, where I connected with the Walt Disney Imagineering in United States, working with the movie industry and the television industry, entertainment industry, and parks and resorts, Disney Cruise, and there's a huge varieties of application within Disney. So that was a great opportunity for me, and it helped me to convert my research into like a tech transfer, create the data science labs in the BC, create companies, writing patents and those kind of stuff. But my strategic move was like to be in a place where I can use the technical things and also the applied to understand why some of these technical things are working and also not working. And also I did another strategic move is generally all these data scientists, they take the data from the data engineering, whatever the data engineers give it to us, they use it and do your magic. But one thing I did initial stage is I wanted to be a data collector. I wanted to understand the journey of the data collector. So someone has to collect this data for me. Right? So when I started to work in the initial stage at Disney, I actually be like a research analysis or a data collector for this movies industry. I went to this, in my projects, right? So I was pretty much the data collector, and I asked supervisor, I want to be that guy. Before I wanted to do the maths and stuff, I want to understand what are the challenges these people are going to have when they are going to bring it, and I want to experience them. So then I know exactly the problems, because as I mentioned in the earlier, this quality of the data. Right? If I put the garbage in, you are going to get the garbage out. So in order to understand this, one thing I did was I want to be a data collector. So I have been in the data field in the parks, and you spend a lot of time with the people, talking to the people. And I don't do any coding, nothing. You spend a huge amount of time in the rain and the sunny environments in there. You talk to people, get the data, you put the cameras, you are like pretty much like a technical officer. You go and do the stuff. And I spent like 2 to 3 years actually to be in that particular role. And I started to work with the students as well. Then I also go to that particular fields. So then I know this is one of the experience I had it, then I can guide them. But I also push the guys to be a data collector. So then you understand the importance of that particular role. Like Sid was mentioned about several supporting roles. That's another one supporting role we don't appreciate at all, because you have the data, you start working it. But someone has to bring that data. Someone has to bring that data from some of these resources.
Ultimately, advanced analytics is only as good as the data that you have, right? I mean, ultimately, that is the key thing. So, Rajitha, because we do only have about 50 minutes, I want to be sure that we stop it. Let me just come back to you, Poornika. I want to ask 2 questions. One is obviously, you came from a Sri Lankan university, started, I'm pretty sure you didn't start. I do apologize, but I may have to ask you to be very crisp around this. How did you end up getting into advanced analytics, and now you're doing a delivery role, number 1. Number 2 is that I think it's a very important ongoing conversation about inclusion and diversity in our tech industries, and how do you feel, what do you think is the future looking like for having our diversity kind of covered in the advanced analytics space? 2 parts of it for you as well.
Okay. So answer the first part of your question, Rohan. I didn't plan to be in advanced analytics. Actually, I started as a network engineer. So I actually mastered in that field for like 11 years. And it was my passion initially to become a network engineer. And I was actually into pre-sales engineering because I wanted to be like half technical, half business. That kind of a role was what I was interested in. So after 11 years being in a network engineering role, and I was very successful in that role, but I felt kind of a bit boring after 11 years. I felt it's not too challenging for me. I was into network solution design. So I was looking for something. I didn't know what I wanted to do, but I felt like I can't be doing the same thing. Like it was evolving, but it's network engineering. So I wanted to do something different, but I didn't actually know what to do. So at that time, in my previous workplace, we had different initiatives, the blockchain, IoT, data. So there are emerging technologies that different set of people were experimenting. So I was lucky enough to get an opportunity to get into the data science or the data analytics field without any prior experience. That's how I actually wanted to get into something new. So that's how I actually started working into analytics, but actually it was not advanced analytics I initially started. It was business intelligence. So I started off with business intelligence. I realized the value of data, even from business intelligence, what's the value that you can deliver to the business. And then I actually started doing small R&D projects within the BI team. And we, of course, had a data engineering team separately. And we do certain experiments with some of the sample data sets we had on advanced analytics. So that's how I actually got into advanced analytics. And I was more into BI, but definitely at the customer front. I was managing the customers and expectations from the business and technical. How do you manage? So that kind of a role I was in. And then pure advanced analytics, I actually got at OCTAVE only. So that's how my journey has been so far. And it's exciting at the moment. And to answer your second question, Rohan, about the diversity, I think we all know in tech industry, if you consider the gender diversity, we see very less women participation in tech industry. It's the same even for advanced analytics. This is not just locally, I think even globally, there's an imbalance. Sure. But I think one of the reasons is there is poor participation from women in STEM fields in the education. But I think it's getting a bit better nowadays. Sort of youngers actually taking up STEM fields in their mainstreams, and I think in future this will be a bit better. But actually, I think the diversity is really, really important, especially in advanced analytics, because what we are doing is we are trying to give analytical solutions to a business problem. So there's a lot of problem solving that happens within when you design an analytics project. And this analytics is a team sport, right? It's delivery, data science, data engineering, everybody comes together and do the problem solving. So it's really important to have multiple perspective of the business at the problem solving session. So that diversity of the workforce actually can bring that different perspective. So I think we might can overlook certain aspects. So male, female, they think differently. So it's not just gender, even other diversities like ethnicity, religion. When people are coming from different backgrounds, they have different perspectives. So you can actually do the problem solving effectively, and your solutions will not be biased. And I think that's one of the main reasons that why we should have diversity in advanced analytics. And at OCTAVE, actually, I think even now we have a very diverse workforce in terms of gender, ethnicity, religion, anything. And we are actually encouraging to have that diversity and keep going with that. So our first priority anyway would be to have the right skill set in terms of knowledge, skills, attitudes, experience, and everything. But within that, we would like to accommodate a diverse workforce so that I think our quality of the solutions will also be very good.
Thanks, Poornika. Appreciate it. I know that we've spent 1 hour and about 21 minutes at the moment. Randula, there was a question from you. I don't think you need to choose between both UI, UX, and data science. I think you can do both. Is my personal opinion. But I think it's again like what Basant said. Like if you're going deep, that's when the time. I think ultimately you're always going to fight for time. So where are you going to allocate more time is the question. Okay, gentlemen and Poornika. Madam, thank you so much for your time. I will just leave asking for your final thoughts about anything for the audience, not to me, to anyone else, but to the audience here. We have about 70 plus here still. Any comments or anything that you want to leave behind, and then we'll wrap up the session for today. So starting with Sid.
So I have a very small comment. So if this is a field which interests you, okay, so don't worry about your background. Don't worry about what you have been doing. Just get into it, right? All the information is available on internet. It might not happen overnight. It might take a little bit of time, but all the skills, all the information is available. Skills can be developed over a period of time. So my only recommendation, if this is the area of your interest, please go online, do your research. There's a lot of content available. There are a lot of portals available which can help you do that.
Excellent. And then Basant?
I think the way I would like to summarize and give suggestion is you should try to join an organization which has that holistic development and learning culture, employee-friendly culture. Let's say you're not able to find that company and then those mentors and colleagues. So you should try to create that culture wherever you join as the starting point. You can be that creating that learning culture and go from there. And as we discussed, I mean, you need to be like a rabbit, like Kalovitana and Jayaweera, attack and try to understand many aspects of these things. Don't be detail oriented in that front, but be detail oriented in things where you need to be, which we discussed, databases under the hood of distributed processing system, and there are many more, right? So that is how I think you should try to approach it. Yeah.
Thank you, Basant. Rajitha, for you, mate.
Yeah, like I mean, completely agree with what Siddarth and Basant mentioned. Like I think you have to take the action first, right? So don't worry about the field that you are in, and if you have the passion, like and if you are willing to put some extra effort, especially in the initial time, just go for it. And we have this the data sets in Kaggle, so you can participate for some of this Kaggle competition, do some exercises, right? So do some data analysis part initially, like if you want to be a data scientist, right? be in the business intelligence field, like similar to what Poornika, she like pretty much said, like I started with the business intelligence, right? So she changed the career, and she wants to be a DS. She started with to be in the data analysis role, did some business intelligence field. That will be a good starting point. And also I put it like a link in the chat as well, so you can go to this data if you are interested, and you can create a resume and you can join with them as well. So they kind of give some exercises for you, and sometimes if they accept that, they have one-to-one person with you, so that might be a good opportunity for you to put like a trainee data scientist, and start that particular journey. So that will be definitely something that you should looking into that. And something that even my interns and some of the students I encourage you to do, to connect with these people, because they are someone one-to-one person connection, and teach them solve problems, understand why some of these things are working. And about these codings and stuff, like this in entire analytical journey for like a data science, only 10-15% is actually using as a coding part. Like all the 80% is pretty much about problem solving, team, working with the teams, dealing with the business problems. That's where there is the entire logic. Like even Basant was mentioning about these things, like it's about how to structure these things. Sorry, the SIP mentioned about these things, how to structure the process. The codings we have, you can Google it, you pretty much copy paste the stuff, right? So the information is pretty much there, but develop this solution design thinking process. So that will be helpful for you. But take the action, fight with yourself. Like you are competing with yourself. You are not competing with your friend. You are pretty much competing with yourself. Think about yourself in 3 months, 6 months ahead. Understand what are the missing pieces we have, and feel it. And it's like a puzzle. And eventually, you will get into that and practice. Like practice. Make sure you practice this thing.
Amazing, Rajitha. Poornika, for your final comments, and we'll wrap up. I'm just getting a lot of messages as well. Very interesting. Thank you so much for everyone. Poornika, your last final comments.
So Rohan, I would like to leave my thoughts with a great quote by a great person. We all know about Albert Einstein, the greatest scientist of the 20th century. So he said once, I have no special talent. I'm just only passionately curious. So I want to draw this quote and relate this to analytics, because in my personal opinion, I think irrespective of your basic knowledge, the theories and everything, curiosity is one of the main traits for an analytics person. Would it be a data scientist, delivery, data engineer, any related role in the advanced analytics? I think curiosity is the number one driving factor, because you are analyzing data. If you have that curiosity, you will go one step ahead. If data is behaving one particular way, you should ask the question why. And if you are more curious, you will ask two questions. So curiosity, I think, is the number one trait, in my personal opinion, that will take you a long way in advanced analytics. So anybody who is interested in getting into advanced analytics, I think that's the trait that you need to activate within you. So I invite you all to be curious and stay curious. Thank you.
I'm the moderator. How can I top that? How do I say something? That's, guys, thanks a lot. Panelists, it's always a privilege and honor to have you guys. I myself learn every time I connect with you guys, Basant. I'm really gonna look up to connecting with you a lot more. There's a lot of interesting stuff I think you and I can connect on. Sid, pleasure. Sorry I'm not in office today, but next time. Rajitha, look forward to welcoming you and seeing you in Colombo more often. Poornika, thank you so much always. And thank you for everyone who has been with us through for 1.5 hours. We hope we added value to you. Look us up on any of the LinkedIn profiles, be connected. A couple of people have asked for some inquiries, much as possible. I've responded to you. I hope we answered your questions. Think of this as whatever it is, maybe the kick that you needed to start something, and pursue this if you think you really believe in it. And I think that's what all of us more or less did. So good luck to you. Thank you so much. And we'll see you next time in our next webinar. Cheers, guys. Thank you so much. Bye.
Thank you.
Thank you so much.